The Earth's atmosphere is a mixture of gases that consist mainly of elemental nitrogen and oxygen. In this video, we will be learning about the properties and behavior of gases, most especially the laws that provides explanation about their behavior. But first, what is a gas? A gas is a state of matter where the particles are spread out. It has no definite shape or volume. A gas also do not have a definite shape. A gas does not have specific size or shape. It fills in the shape of its container. Additionally, a gas has no definite volume. Gas expands to fill up the space inside its container. The amount of space occupied by a gas may change depending on the volume of its container. So the question now is, how do we explain the behavior of gases in various conditions? This is where gas laws comes in. Gas laws helps us understand the relationship between pressure, volume, and temperature which govern the behavior of gases in various conditions. That is why this lecture video will help you. First, understand Boyle's law thoroughly. Second, learn about Charles's law applications, and third, explore the ideal gas law implications. You will also be expected to analyze gas behavior under different conditions, apply laws to scientific problems, and relate gas laws to everyday life. In a gas, its physical behavior is described by four variables: pressure, volume, temperature, and amount or mole. And understanding these things are the essentials in gas laws, in order to explain the behavior of gases. First, we will have the Boyle's law, which is concerned in the relationship of pressure and volume. Boyle's law was formulated by the famous scientist Robert Boyle in 1662. This law relates the expansion and compression of the gas at constant temperature. In his experiment, he has a J-shaped tube with a shorter end closed and the long end open. Having all the data from his conducted experiment, he then find out that volume and pressure follows this graph as shown. We can see on the graph that volume is inversely proportional to pressure. When we write it in mathematical terms, we have pressure times volume equals a constant. If we have a gas under two different conditions, we can write the formula as initial pressure time initial volume is equal to P2 time volume 2. Or P1 time V1 is equal to P2 times V2 in the formula. We can see that under a certain condition of a gas, increasing the pressure would result to decreasing volume or vice versa. For us to better understand Charles' law, let's have an experiment. Experiment time.
From the experiment, as we close the tip of the syringe and pull the plunger, resulting to the decrease in pressure, the volume of the marshmallow increases. On the other hand, as we push the plunger in, increasing the pressure inside the syringe, the volume of the marshmallow decreases. This inverse relationship of volume and pressure in this experiment perfectly shows Boyle's law.
Now we have this sample problem with us. A gas occupies 100.00 milliliters at 150.00 kilopascals. Find its volume at 200.00 kilopascals. So the given V1 equals 100.00 milliliters. P1 equals 150.00 kilopascals. V2 equals P2 equals 200.00 kilopascals. Formula: P1V1 equals P2V2. Solution: 150 kilopascals times 100 milliliters equals 200 kilopascals times V2. Cancel out kilopascals, and the answer is V2 equals 75.0 milliliters. Next is Charles's law. This law is concerned in the relationship of volume and temperature. This law was formulated by the famous scientist Jacques Charles less than 2 centuries after Boyle in 1800s. This law describes how gases will expand when heated. In his experiment, he prepared a test tube with air under a small mercury plug. It was immersed in water bath for heating and cooled with ice. Upon changing the temperature, the volume of the gas dropped and the test tube also changes. Having all the data, he found out that the volume and pressure follow this graph. As shown, it can be seen in the graph that there is a dashed line portion because theoretically, when a gas reach absolute zero temperature or 273.15 degrees Celsius, the gas occupies zero volume, but no one has ever seen this phenomenon. When we write it in mathematical term, we have volume is directly proportional to temperature. This can also be written as V, which is volume over T, which is temperature, is equal to some constant. If we have a gas under two different conditions, we can write the formula as V1 over T1 is equal to V2 over T2. In this formula, we can see that under a certain condition of a gas, increasing the volume would result to increased temperature, or decrease in volume equals decrease in temperature. For us to better understand Charles' law, let's have an experiment. Experiment time.
In this experiment, we observed that as we put the inflated balloon on a hot water, its size slightly increases, but as we transfer it to the cold water, that cold temperature shrinks the balloon. This is because the air particles inside the balloon experience an increase in kinetic energy as the temperature increases that results to the increase in the balloon's volume. And as the temperature drops, the kinetic energy of the gas particles also decreases. This shows now direct relationship between volume and temperature, which Charles's law exhibits. Let's try to solve.
A gas occupies 473 cubic centimeter at 36 degrees Celsius. Find its volume at 94 degrees Celsius. Given V1 equals 473 cubic centimeter, T1 equals 36 degrees Celsius equals 309 Kelvin. V2 equals missing. T2 equals 94 degrees Celsius equals 367 Kelvin. Formula: V1 T1 equals V2 T2. Derivation: V1 T2 equals V2 T1. So given this derived formula, we can now solve the problem. 473 cc, 367 K, equals V2, 309 K, answer. V2 equals 562 cc. Next is ideal gas law. It is important to understand that the ideal gas law is based on experimental measurements of the properties of gas. Combining the other gas law, namely Boyle's law, Charles's law, and Avogadro's law, and changing the sign of proportionality to the sign of equality, we will have pressure in atmosphere time volume in liters equals moles time temperature in Kelvin times proportionality constant. Calculate the pressure in atmospheres of 0.412 moles of He at 16 degrees Celsius and occupying 3.25 liters. Given P is missing N equals 0.412 moles. T equals 16 degrees Celsius equals 289 Kelvin. V equals 3.25 liters. R equals 0.0821 liter atmospheres per mole Kelvin. Formula. PV equals nRT. Solution. P times 3.25 liters equals 0.412 moles times 0.0821 liter atmospheres per mole Kelvin times 289 Kelvin. Answer. P equals 3.01 atmospheres. Thank you for listening. Hope you learned something ka agam.